All the circuits you've studied so far have been series circuits. There is another kind of circuit that you use in your everyday life when you turn on lights or appliances in your home. These are called parallel circuits.
A parallel circuit is one that has more than one complete path for current to follow, with a common voltage source for all paths. This schematic diagram shows two lamps connected in parallel across a 12-volt source. Notice that the wire termination dots on the schematic indicate several wires are connected to the same terminal.
In wiring circuits, it isn't good practice to place two or more wires under the same terminal screw or post. This can cause loose connections. These connections should be made using U-shaped terminal loops.
After wiring the circuit, voltmeters are connected across both lamps and the source. When the circuit switch is closed, the voltmeters indicate that all voltages are equal.
Each load in a parallel circuit has the same voltage applied across each resistance, so therefore must have the same voltage rating for proper operation.
Now, let's add 3 ammeters to this circuit, as shown in this schematic diagram. The purpose of the ammeter, AT, is to measure total current in the circuit. Ammeter A1 to measure current through lamp 1, and ammeter A2 to measure current through lamp 2. This is how the completed circuit looks. When connecting ammeters in a circuit, remember meter polarity must be observed. In this circuit, the negative terminals of ammeters A1 and A2 are connected to the common return of the negative terminal of the power supply. Conversely, the negative lead of ammeter AT is connected directly to the negative terminal of the power supply. Closing the circuit switch, ammeter AT indicates 0.69 amperes, and ammeters A1 and A2 indicate 0.34 and 0.35 amperes respectively. Now, add a third lamp with an ammeter A3 in parallel with 2 other lamps as indicated in this schematic. Each separate path in a parallel circuit is called a branch. Therefore, there are 3 branches in this circuit. With the third lamp and ammeter wired in place, close the circuit switch and read the current flow in the 3 branches and the total current. Ammeter AT reads 1 ampere, and ammeters A1, A2, and A3 read 0.33 amperes each.
So, analyzing the results of the meter readings we've taken leads us to draw 2 conclusions. Number 1, adding a parallel load to a circuit increases total current. Number 2, total current, 1 ampere in this case, is equal to the sum of all the branch currents.
In the same circuit, let's replace the equal wattage lamps with 3 lamps of different wattage ratings. Lamp 1 is 40 watts. Lamp 2 is 20 watts, and lamp 3 is 10 watts. Close the circuit switch and read all meters. Notice the difference in the brightness of the lamps and in the ammeter readings. The total current, IT, as read by the ammeter, is 1.08 amperes. The current of lamp 1 is 0.59 amperes. The current through lamp 2 is 0.33 amperes. And the current through the third lamp is 0.15 amperes.
All branch currents in a parallel circuit are determined by 2 things: the resistance of the branch and the voltage applied across the branch. Well, we know that the voltage in a parallel circuit is the same across all branches, so that means the more resistance there is in a branch, the less current in that branch.
The lesser resistance of the 20-watt lamp causes a greater current to flow. That's why lamp 2 draws 0.33 amperes. The total current in a parallel circuit depends on the source voltage divided by the total resistance of the circuit, or I total equals V total divided by R total.
Since each branch in a parallel circuit carries its own separate current, the branch's current can be calculated.
By using Ohm's law, the current of the branch is equal to the voltage total divided by the resistance of the branch. In parallel circuits, the current to and from the battery source is the sum of the branch currents. The total current is equal to the sum of all the branch currents. This rule is known as Kirchhoff's current law. The current that enters a point in a circuit is equal to the current that leaves that point.